Yes, you are welcome to continuation of our discussions on topics in abstract algebra. Today we are going to begin discussions on permutation groups. We shall begin with general notation. I welcome you to illustration. Yes, you are welcome to continuation of our discussions on permutation group. As I said, we are going to begin with general notations. So to begin with, number one, what is permutation? Permutation is a map, a bijective map. Let me call it X from omega to omega, where omega is alpha 1, alpha 2. Okay. So what we mean is that a permutation is a bijective map. Let's call it X, denoted by X from omega to omega. Omega is a non-empty set containing elements alpha 1, alpha 2 to alpha n. Now, omega is always finite because permutation groups are always finite. So omega has to be finite set. Now, then the elements of omega, these elements, that is alpha 1, alpha 2, up to alpha n, are called points. So as a general notation, we are going to be calling them points instead of elements. We shall see why, because the cycles contain elements of omega and they are not separated by commas. So we shall call them points, okay, of omega. Then number 3, the map alpha 1 to alpha 2, alpha 2 to alpha 3, dash dash alpha n minus 1 to alpha n and alpha n back to alpha 1, okay, produces what we call a cycle. So we write it like this: alpha 1 without comma, alpha 2, alpha 3, dash dash alpha n, like this. So when we write like this, what we mean is that alpha 1 is mapped onto alpha 2. Alpha 2 is mapped onto alpha 3. Dash dash up to alpha n is mapped back to alpha 1. If you call this star, then star is called a cycle, okay, of course, of length n. So that means, and that takes us to number 4, okay, the number of distinct points in a cycle is called the length of the cycle. I'll give you an example. If I have a cycle like this, 1, 2, 3. This is cycle where 1 is mapped to 2, okay? 2 is mapped to 3, and 3 is mapped back to 1, okay? So, and the number of decision points, 1, 2, 3 is 3. So the cycles, so the number, the length of cycle, length of cycle 1, 2, 3 is 3. So it's also the length of something like 7, 8, 5. It's also, the length is also 3, and so on and so forth, okay? So cycles have some interesting property. For example, when I write 7, 8, 3, this cycle is the same as 8, 3, 7. It's also the same as 3, 7, 8. They are all the same. They represent the same because in each of them, 7 is always mapped to 8. 7 is mapped to 8. 7 is mapped to 8. 8 is mapped onto 3. 8 is mapped to 3 here. 8 is mapped to 3. 3 is mapped to 7. 3 is mapped to 7. 3 is mapped to 7. So they are all equal. Now I will welcome you to the next presentation. I will continue with the notations.